All right, here it is. This is the big trig lesson from Chapter 8. Chapter 8, this unit, as we said, is only those four sections, 8.2, 8.3, 8.4, 8.5. Of course, 8.2 and 8.3 are behind you and hasn't seemed very trigonometric yet, but this is the one, 8.4. This is the one where we describe the sine, cosine, and tangent ratios. That's the big one there. Those are the ones you've probably been scared of. And I don't know, to help you not be so anxious about this chapter, I guess today is it. We do sine, cosine, tangent on 8.4, and then in 8.5, it's just story problems about those. So, I don't know, 8.4 is kind of the pinnacle of this whole thing, but then after that it gets easier. All right, trigonometry. This is really where trigonometry technically starts. And all it really means, I mean, if you think about the root of this word, tri for three, gon is like polygon, like number of sides, and metry is about measuring. So it's about trigon is a triangle, and metry is measuring that. It's about measuring the sides of a triangle. It's about how the angles and the sides of a triangle are related. And so far, all the stuff we've done with triangles, like we've talked about how the sides can kind of be related, and we've talked about how the angles can kind of be related. Other than Pythagorean theorem and I guess special right triangles, until now, we haven't really done how you can figure out the angles from the sides and how you can figure out the sides from the angles. And that's what this is really about. So, a trigonometric ratio is the ratio of lengths of two sides of a right triangle. And now think about that. Two sides of a right triangle, that could be the two legs. It could be the hypotenuse in a leg. So two sides is, not as easy as it kind of sounds when you just read that the first time. Trigonometric ratios give the relationship between the different combinations of the sides in a right triangle. This whole unit is called right triangles. So still, we are just talking about right triangles. Sides are named as adjacent or opposite, referenced to an acute angle. So let's look at this. In the diagram below, which is this, if we're talking about angle C, so in all of this, C, this angle, this is the angle we're talking about. So in reference to angle C. So angle C is the important angle. And as we go through this, sometimes I could have chosen, C to be the angle or A to be the angle. In this whole page right here, we're choosing C to be the angle. If we choose C to be the angle, then we're going to give names to these different sides. And those names are this: opposite, adjacent, and hypotenuse. The name hypotenuse is one you've been kind of used to. Hypotenuse has to be this side. Hypotenuse is not the one that's going to confuse you. The ones that are going to confuse you, the ones you have to kind of think about, are opposite and adjacent, and they are very important. Now again, once we've picked the angle to be C, now we assign these names opposite and adjacent. So opposite, we're talking about opposite to angle C, and adjacent means adjacent to angle C. So these two legs, the two sides that meet at the right angle, one of them we're going to call opposite, one of them we're going to call adjacent. And again, we mean opposite or adjacent to angle C. So here we go. Opposite to angle C would be this one. And adjacent to angle C would be this one. Notice if I had picked angle A, those names would be totally different. Because then now this side next to angle A is not opposite anymore, it's adjacent. So it all depends on this angle. And again, I don't know, maybe I don't have to say this again, but this whole idea of trigonometry is about relating angles to sides. So it's about picking the angle and then naming the sides based on what you call, which angle you picked. So we picked angle C, so that all of a sudden, by virtue of picking angle C, that assigns the names opposite and adjacent to these sides as such. Okay, so after all that, here we go. Sine, cosine, and tangent. Sine is AB over AC. So sine of C, sine of angle C, this is the first time you've ever heard this, the sine of angle C is the ratio of this side divided by this side. The cosine of angle C is this side divided by this side, and the tangent of angle C is this side divided by this side. So if you could think about that relative to angle C, or if you could pick any two sides in the triangle, there's actually three different pairs you could pick. You could pick the two. You could pick the two perpendicular sides. You could pick one of the perpendicular sides with a hypotenuse, the other perpendicular side with a hypotenuse, and those are the three possible pairs you could pick. That's why there are three of these things. This one, I'm going to put it right in here. This one is, what is AB? Oh, AB is the opposite, isn't it? And sine AC is, side AC is the hypotenuse. I'm going to write these in. The cosine of C is BC. Okay, BC is the adjacent side, and AC is the hypotenuse. In the tangent, AB would be the opposite side, and BC is the adjacent side. So if you think about how these are named, I have a different pair every time. And there's only three possible pairings you could pick, and here they are. So that's why we get what we get. In reference to angle A, okay, so let's start over. I'm just going to erase everything. Okay. Oh, I shouldn't erase that. Nothing wrong with that. But instead of highlighting angle C, I'm going to highlight angle A. If I was to highlight angle A, everything's different now in terms of opposite and adjacent hypotenuse. What's the angle? What's the side opposite angle A? Well, opposite angle A is down here now. Adjacent to angle A, well, that's over here now. Hypotenuse again hasn't really changed. But notice that notice that the sine of A, BC, BC was the opposite side. AC is the hypotenuse. Whoops. Hey, AC is the hypotenuse. AB is the adjacent side. AC is the hypotenuse. And these are just the definitions, so you're supposed to believe these. All right, BC is the opposite side, and AB is the adjacent side. So what's true about all these definitions? Well, sine is opposite over hypotenuse. Yes. Cosine is adjacent over hypotenuse. Yes. Tangent is opposite over adjacent. Yes. What sort of changes here, like why these are different than these, is because we're talking about angle C versus angle A. And that changes which one's the opposite, which one's the adjacent. But what's constant in all this is the sine was always opposite over hypotenuse, cosine was always adjacent over hypotenuse, and tangent was always opposite over adjacent. And those are the definitions of what sine and cosine and tangent mean. Those buttons on your calculator, sine, cosine, tangent, you should see those on there. Or actually, they're not buttons on your calculator. They're in a menu. They're buttons on older calculators and on your iPhone. That's what they mean. They mean these three things. Sine, check this out. Sine, I'm just going to highlight the S, equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. I could write that as sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent, which is why we write them this way a lot. And this is the way you're supposed to remember those. Sohcahtoa sounds like an ancient Native American chief name. I'll tell you the story in class, but Chief Sohcahtoa is very important in the history of trigonometry. Sohcahtoa. Get used to that. There's a poster in my room that says Sohcahtoa. Okay, that's how you remember that. That's a definition. It's not a theorem, so it's not on the theorem list you get during the test. It's a definition. You're supposed to remember that by itself. But you know what? That's why we have these super awesome mnemonic devices. Okay. Problems in the right triangle trigonometry fall into two categories. Either they're going to give you an acute angle in one side of a right triangle are given, and you have to find some other side, or they're going to give you two sides, and you have to find an angle. You know what? Let me rewrite these another way. Instead of writing it that way, because you have that below. I was thinking about this a second ago. Why don't we write this way? Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. In each one of these relationships, there's a trigonometric ratio, and there's two lengths of a triangle. And the way these problems could possibly work is they're going to give you two of these things. Like they're going to give you like this, and you have to find the third thing. So either they're going to give you two lengths, and you have to find the angle, because this thing over here stands for an angle, or you're going to get an angle and one of the sides, you're going to find the other side. That's what these two categories are about. To find the missing side length or angle measure, you must look at how these sides are related to the angle, opposite, adjacent, or hypotenuse, and choose the correct trigonometric ratio. So a lot of this is trying to figure out, okay, is what I'm looking at with what I'm given in a triangle, if I'm given two different sides, if I'm given that side, maybe in that side, and I'm asked to find this angle, I have to decide, okay, well, should I be thinking about sine, should I be thinking about cosine, or tangent? In this one, the one I just gave, since that's the angle we're talking about, and say maybe I knew that side, and I know that side, well, this side's the hypotenuse, so that would be that one or that one. This side relative to that angle would be opposite. Oh, so I guess I would need sine in that case. So it's that type of thing. Since the values of the tangent ratio are fixed to a specific angle, actually not just tangent, any trig ratio, are fixed to a specific angle, we can use a table of values or the calculator to find these values if necessary. So once we know the angle, the sine or the cosine or the tangent of that angle is always the same. You could put in, so for this problem, we're going to use angle size 42 degrees. You put in your calculator, sine 42 or cosine 42 or tangent 42, it knows. It knows what that ratio should be. Sine of 42, the ratio of the opposite and the hypotenuse in that triangle should be a specific ratio. Or the cosine of that angle should be a specific ratio, or the tangent should be a specific ratio, no matter what the size of that triangle actually is. Oops. All right. Find the values of x and y to correct two decimal places. Do you expect do you expect y to be bigger or smaller than AC? Okay, let's think about that first, actually. If this is 42 degrees, do you expect x to be bigger than 6? Y to be bigger than 6? Do we have any idea? Well, let's think about that. Well, certainly x has to be bigger than 6 because x is the hypotenuse of this triangle. X has to be the biggest side of this triangle. So certainly x is bigger than 6. A bit harder question is, which is bigger, y or 6? Well, we did this last chapter, last lesson. We were talking about isosceles right triangles. So let's say they were both 6. If they're both 6, what's that angle supposed to be? That angle would be congruent to that angle because these are, isosceles triangles. They would both be 45 degrees. So if this was 45 degrees, this would be 6 and this would be 6. Or if you think about it this way, if I drew a 45-degree angle in there, okay, first of all, where would the 45-degree angle go there? If we do a 45-degree angle here at A, 45 degrees would go kind of bigger than where it is currently. Not a whole lot, but slightly bigger. If we did that and went up to here on this triangle, made this triangle here, that whole thing would be 6. So I kind of expect that y should be less than 6, because this is only 42 degrees, so it's going to be a little bit smaller. Okay, so that stuff is actually pretty good. That's going to help you when it comes to test time. Like if you can estimate which side's supposed to be the long side and the short side, kind of like we did in 8.3, that's going to be helpful at the end when you get to sort of estimate which one's going to be bigger, smaller, etc. Okay, so anyway, it says find the values of x and y. Correct to two decimal places. So I'm supposed to be actually able to find these. All right, so let's go back to those trig ratios of Sohcahtoa. Relative to the 42, let's just write them all out first. The sine of 42 is supposed to be opposite over hypotenuse. The side that's opposite to 42 is y. The side that's hypotenuse in this triangle is x. This isn't very helpful because it's two variables. I can't really do much with that. The cosine of 42 is supposed to be the adjacent side. Well, the adjacent side to 42 is 6. The hypotenuse is x. And so that's going to be helpful. I have to kind of finish this out quick because the video is going to stop me. Tangent of 42 is opposite, which is y, over the adjacent, which is 6. I'll stop right there and I'll pick up in part 2.